Dear brothers and sisters and the respective elders, this is the video presentation on boiler drum level control and boiler combustion control. I will explain this briefly using different ways of techniques. So please watch till the end if your main control objective is to learn boiler drum level control and boiler combustion control. So, first of all, what is boiler drum level and boiler combustion? These both are actually combined to form a boiler. Generally, boilers are used in industries to generate steam, which in turn it is used to generate power and heat. It consists of two main parts, as I have already told that one is furnace or boiler combustion and second is boiler propel or boiler drum. Furnace or boiler combustion provides heat by burning the fuel using air and fuel inlet, where boiler drum is the part where water changes into steam due to heat. This steam, which is flowing outwards, is used for certain processes like heating applications. Water, which is fed into the boiler drum, is called boiler feed water. Okay, then coming to the boiler drum level control. What is the main control objective of boiler drum level control? It is nothing but a level of water. Yes, our main motto is to control the height of the water inside boiler drum using feedback loop, where our control variable is height. Here, this is the schematic diagram of boiler drum level control, and this is the boiler drum which is having a water in it, and this is the level measurement sensor which measures the height of the water level in boiler drum. It will send the values through voltage transmission line to the controller, and the controller will take a certain decisions according to our request, and it will give a signals to the control valve, so that control valve will take actions like it will control the flow of feed water which is flowing into the boiler drum. And it will convert into steam according to a boiler combustion. And this is nothing but a single element boiler drum level control. Why? Because it is called as single element, because it measures only one value. There are having some problems in this, so let's discuss about some problems. Okay, next coming to the problems of boiler drum level control, let's discuss about the main problems of boiler drum level control. If liquid is low, then energy will be absorbed by building structure and leads to damage. If liquid level is too high, then liquid droplets may come with steam, so it leads to corrosion in pipes. And the disturbances in boiler drum level control is steam. More steam is going out, then height will decrease. Feed water. If feed pressure is decreased, then there will be changes in flow of feed water. So, how do we get rid of this? Then coming to the solutions to get rid of those problems. Disturbance is affecting the manipulated variable, which is nothing but flow of feed water. Then to get rid of this, we have to include cascade control structure to the boiler. Cascade control structure, which is nothing but a control structure which is having two loops. One is master loop and another one is slave loop. Like here, master loop is measuring the level transmitter which is connecting to the level controller. It is called the master loop, and the slave loop is nothing but a flow transmitter of manipulated variable. From manipulated variable, our flow can be measured using flow sensor, and it will be transmitted to the flow controller. So, also, if we include feed forward loop in this boiler drum level control, by including this cascade control structure loop and feed forward loop in this control system, then it will become a 3-element method of boiler drum level control. Okay, Let's discuss about 3-element method of boiler drum level control. 3-element drum level control is suited for handling variable feed water pressure or multiple boilers with multiple feed water pumps. In this design, 3 elements are used, each for controlling level, steam and feed water flow respectively. This system offers far better and advanced drum level control as compared to all other systems. For better control, correct flow values of both steam as well as feed water must be maintained with regard to density. A typical drum level control with 3-element module is shown in the figure below. Let's discuss from this image. This is the drum level sensor which transmits the height of the level water to the controller. Feed water flow, it is also measuring the flow and it is also going to the controller. And the output steam flow, and it was also measuring, and it is measuring and it is transmitted to the controller, and it will act as a feed forward loop, and drum level and water flow will act as a cascade control structure. Okay, let's discuss briefly in a deep manner. This is the piping and instrumentation diagram of boiler drum level control. Okay, 3-element method is nothing but having 3 transmitters which is having 3 measurements like input water flow, level, output steam flow. This is actually most efficient method to control the drum level. See, cascade control structure is over here, having 2 measurements to avoid the disturbance. Then we have to measure manipulated variable, also including level, which is our control variable. Here steam is the feed forward. Level transmitter will transmit the level of the water to the level controller, which is nothing but it lies in the master loop of cascade control structure, and it will send the value to the flow controller. Flow transmitter will take the value from feed forward flow rate and it will send to the flow controller, and it will analyze the value according to our request, and it will give a signal to the control valve, which is nothing but manual control element. It will control the flow of water, feed water flow. See, this is actually a better approach compared with the single element or 2 elements like cascade control structure. Why? Because we are actually measuring disturbances like output steam flow, and we are also measuring the manipulated variable, which is nothing but an input water flow, so that we can control the level of water efficiently using 3 elements. Now coming to the combustion control, as I have already discussed how the boiler combustion works. Now we can concentrate on controlling of boiler combustion. Okay, tell me, what is the main control objective of boiler combustion control? See, to avail proper combustion using air fuel ratio to maintain the heat to produce steam as well as to control the level of water, which is actually the main control objective. Now we will discuss about problems and its solutions. As more and more water vapor increases in boiler, which is like balloon, and it leads to increase in pressure, which leads to burst or blast of boiler tank. So to get rid of this, we have to include pressure measurement of boiler. I am going to briefly describe how boiler combustion works, and I will just summarize the boiler drum level control. Okay.
Hello everybody. Okay, now I'm going to describe briefly regarding how boiler drum level control and boiler combustion control will work. Actually, I have already discussed about boiler drum level control, but I will just summarize regarding the boiler drum level control, and regarding boiler combustion control, I will explain each and everything. Okay, just follow me. I will draw the diagram of boiler. have told, this is boiler drum. This is boiler drum level, and this is controlling parameters that we are controlling the boiler drum, and this is boiler combustion. First, I have to explain how the boiler drum level. I will just summarize. Why? Because I have already explained you regarding the boiler drum level control. Okay. First of all, I will explain how it is working. What is main control objective? I have told the height. Height was the main control objective. So, for controlling the height, level transmitter, it will measure the height of the level of the water, and it will send the measured distance level to the level controller, and according to our set point, it will analyze and give the signal to the flow controller, which is nothing but it is the main controller of the master loop of cascade control structure, and this is the flow control. This is the second control, which is inside the slave loop in cascade control structure. We are this cascade control structure, and this is actually feed forward. This is nothing but steam going outwards. Why? Because you know that due to boiler combustion, the water will be evaporate and it will be converted into water vapor, and the steam can be useful for the heating applications. And so we can do directly using level transmitter to our main control objective is to control the height. But why we are including these things? Why? Because this is the disturbance. What is this? This is the feed water. Input feed water. For here, imagine if pressure was decreased, feed pressure over here. If feed pressure is decreased, then automatically the flow of the feed water will also decrease. So we may think that according to our algorithm, given algorithm, we used to analyze that the flow of the water was 0 to 100%, but due to decrease in feed pressure, due to these disturbances, it may affect the flow of the feed water. So we are just measuring this input flow. So we are measuring the flow also. So we are connecting this flow transmitter, will measure the flow of the input feed water, and it will send to the flow controller. And flow controller is nothing but, I have already told, it is included in the inner loop of cascade control structure. Cascade control structure, this is the cascade control structure. But you may have a doubt, why we are measuring the output steam flow? Why? Because for example, this is also a disturbance. Why? Because if the steam is increased, then level in the water will be decreased. If the level in the water was decreased, the energy will be taken by the boiler, and it will taken and it will blast. So if we can control the steam also, so we are also measuring the output flow of steam flow, like attaching a sensor, so it will measure the flow of output steam and it will transmit the value to the flow controller, and this is the feed forward. Why? Because it is a feed forward, it is a disturbance. So we are just reducing the disturbance directly and connecting to the flow controller, so that the settling time will be very in a less settling time it will be settled, so we get a stable system. So this is the three elements. Why it is called three element? I have told that there are three, we are using three measurements, one for level and another for input feed water and another for output steam flow. So this is the boiler drum level. But coming to the boiler combustion, how it is controlled? See, this is the boiler combustion. There will be the combustion process will take place. Combustion is nothing but heating. So in two pipes, as you have seen here, one is for the air, it will flow the air, and one is for fuel. So we need to control this. For that, like for this much air, for this much fuel the combustion will be efficient, so we must have a okay. Now I have told that we must have a perfect ratios like this much 3 is to 5 ratio of air fuel ratio for getting a combustion process efficiency. So for getting a perfect ratio we need to control this flow also. So for controlling this flow we are just initiating the another control structure. The perfect control structure for this is ratio control. Ratio control is nothing but we are just measuring these two flows, and according to that our desired ratio algorithm will be put it over the controller, and it will analyze and it will give the action to the control valve. You may think that why this was controlling, fuel was controlling, but why not air? Why? Because see, uh, air is not controlled over here, but fuel is controlled. Why? Fuel is very costly, air is cheaper. So if we control the fuel, automatically we are just controlling the cost also. I have discussed about ratio control structure, that we are controlling the flow of the fuel. So the ratio of the air fuel ratio will be controlled over here by the ratio control structure. This is called the ratio control structure. Okay. Now you may think we must have a safety control also. See, for example, if the temperature limit of this boiler combustion was increased to a certain limit, then it may have blast, and we may get a damaged conditions, and it will cause environmental problems also. So we need to have a certain temperature safety also. So we are integrating a temperature controller over here, and we will put in the temperature safety limit. So if it crosses that limit, and it will stop the flow of the air through this controller, it will give a signal to the valve, pneumatic valve. So it will stop the airflow. So the combustion will be stopped suddenly. We can integrate this type of process using PLC. You know, PLC is the programming logic controllers. Using programming logic controllers, we can implement this type of application. And you may think the output stream flow also. If the output stream flow temperature increases, and the storage of the steam will also blast, so we need to control the temperature of the output stream also. So for that we are controlling the output stream temperature using temperature sensors. For temperature sensors, you may think which type of sensors we are using. So see, these types of boilers are not usually find everywhere. These types of boilers are found in huge industries. So for the big industries, and the temperature is very huge high, you can't implement a small sensors and little type of sensors. So sensors can't bear that much of temperature. So for that we need to use a optical type of sensors. That is called pyrometer sensor. Pyrometer sensor will measure the temperature of the output steam flow, and it will transmit the temperature value to the controller. So we can give the temperature set point for the temperature controller, and it will give signal to the safety box, and it will send the signal to the pneumatic valve, and the pneumatic valve will control the flow of air, and we can stop the combustion immediately. So using this application, you may think which type of control structure it is. Actually, this is the override control structure. This is the one of the control structure which is mainly implemented for the safety purposes. This is called the override control structure. Override control structure. So the different type of control structures are implemented. And see, assume this thing. For example, if the steam inside the boiler is more enough, we for example we need to measure this in steam inside the boiler also. Why? Because imagine if the steam boiler has balloon. If the gas inside the balloon is increased so much and so much, what will happen? It will blast or burst. So for that purpose, we need to control this steam inside the boiler also. So for that, we are just integrating a pressure transmitter. We are just measuring a pressure. We are just measuring a pressure inside the boiler. So sensor will measure the pressure and it will transmit to the pressure controller, and it will give signal to the pneumatic valve whether steam will be uh, released or not. So if pressure is increased to certain limit, we can put a algorithm over here, so that if pressure increased to a certain limit, then it will release the pneumatic valve will be released and the steam will be flow, and we can't release that type of steam to the environmental conditions directly. In that case, we can attach this pipe to any other stack or something. Okay, and after chemical reactions we can use that. So in this here we are using different type of control structures and different type of things. You may think, why we are using in this much type of control structures? It may cause so much of cost and huge complex type and everything. And see, I have already told, these are not used in small homes or something. These are useful in very big industries. So in that big industries, there must have a high safety approach and efficiency. Okay, so we have discussed each and every type of control structures. This is nothing but there are so many loops over here. Now we can discuss the summary of this concept, how it is working. Okay, we have discussed about 3-element control structure type in a boiler drum level control using 3 element, because it is so much of efficient compared with single element or 2 element like cascade control structure. And we have discussed about boiler combustion control, and we have discussed about different type of control structures we have used in this diagram, in this approach application. Okay, now there are so many loops over here, like this is the feedback loop, one feedback loop, and this is override control is one loop, total 2 loops, and ratio control is 1 loop, total 3 loops, and cascade control has 2 loops, so total 5 loops, and feedback loop for temperature safety, total 6 loops, and feed forward loop, total 7 loops. So we are having totally 7 loops over here. We have used 7 different type of loops to control boiler drum level and boiler combustion. So using this application, we are actually generating a steam which will be useful in heating applications, like we can use those steams for generating electricity or some heating applications. So for that generating of steam, we must control the height. So our main control objective was not the steam, the height. The steam will be described as a disturbance actually. Okay, so we have discussed each and everything briefly and well manner. So these are the boiler drum level control and boiler combustion control. Thank you.
Now, coming to the summary of this concept, there are so many control structures in boiler drum level control and combustion control. There are so many control loops in these two control systems. There are 2 loops in cascade control structure. One loop is level transmitter loop, and another one is the loop which is measuring the input flow. And one feed forward loop, one loop to maintain the steam temperature which is feedback, one loop for ratio control structure, one loop for override control, and one loop for pressure safety control system which is also a feedback loop. Okay, total we are having 7 loops. Also discussed about 3-element control structure, which is nothing but cascade control structure plus feed forward loop. These are the references we have used: Control Loop Foundation Instrument and Tool, YouTube, process dynamic modeling and control Baba Tunde, Wikipedia, and few internet sites, journals, and YouTube videos. And thanks for the Google. We have used so many important internet sites from them. Thank you. Thank you so much for seeing this video using your precious time. And I hope you got very well in this concept. Thank you.